Hi, this is Mr. Huber speaking to you. I just wanted to give you a quick recap of Friday's lesson, where we introduced three trigonometric ratios. Sine A is opposite over hypotenuse, and cosine A adjacent over hypotenuse, and tangent A opposite over adjacent. Well, for that, we used more or less this drawing, where you have 1, 2, and 3 similar triangles. Well, 3 to 5 is like 6 to 10 is like 9 to 15. These are the ratios. So for this particular angle, you'll always get these ratios. That's why we introduced a name for that ratio, and that was the name sine A, which was defined by opposite over hypotenuse. Well, for this angle, this is the opposite side. In German, Gegenkathete. For this angle, this would be the opposite side for this angle. Well, we're talking about this now, opposite over hypotenuse. This is the hypotenuse because it's the longest side, the one opposite to the right angle. This side would be called adjacent, in German, Ankathete. Look, adjacent, this is the anliegende Seite, the Ankathete. Well, we have introduced these ratios to cosine A adjacent over hypotenuse and tangent A opposite over adjacent. Well, you can see they use normal letters, Arabic letters. Here, well, we prefer Greek letters, but it doesn't matter, it's the same thing. As an example, here we're given the hypotenuse. We don't know the height, but we know the angle. So we can set up this equation. Sine of A is opposite over hypotenuse. Well, sine of 40 degrees is h over 12. So out of the three, we know two values. So we can isolate h, use our calculator, and then work out that the height is 7.71 meters. Another example here, very interesting. Here we're given two sides, the hypotenuse, and one of the legs, the opposite leg again, but we don't know the angle A or alpha. But we can still use the same equation, so we get sine of A is 7/12. But the problem is we now want to have the value of the angle, and for that we have to use the inverse sign, okay? The key sine to the -1, or as we call it, arc sine. But on our calculator, this is the button, the key sine to the -1. So you use that button and you get the angle 35.7. Well, let's just get back to this. We have now the three ratios: sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. But it depends. If you took this one as beta, for example, then cosine beta would be adjacent over the hypotenuse. But now for cosine, this is the adjacent side, and this is the hypotenuse still, it's the longest side. And for beta, this would be the opposite side. So if you wanted to use cosine beta, it would be cosine beta is equal to adjacent over hypotenuse. But this would be the adjacent side for beta. Now here, tangent alpha, well, you have opposite over adjacent. For beta, if we took beta here, this would be the opposite, and this would be the adjacent side for this angle. Well, one last example. Well, here we're given the angle and one of the legs, the longer one of the two. So we can use this ratio. Tangent 28 is equal to h over 12.4. we isolate h. That means h is 12.4 times tangent 28, and we get the length of h. Here, we're given two sides again. We don't know the angle. Well, one of the sides is adjacent to this angle. This is this vertical side here, and 16 the hypotenuse. So adjacent over hypotenuse. We know 2 out of the 3. Again, we want to know the angle, so we have to use the inverse cosine, or as we call it, arc cosine. So I hope this helped, and I'll see you in the next one.